Okay, good afternoon. This is Professor David J. De Los Reyes. My topic this afternoon will be the concept and how remote controlled toy cars operate. Remote controlled toy cars operate. How does this one operate? Okay, so for those who would like to find how this toy car operates, I will try to explain on the board, but this will now be a summary. Okay, let's proceed. I'll go to the board to explain the concept and how this toy car operates. For remote controlled toy cars, okay, this is how it operates. uh, I have given you two block diagrams on the board. The first one is the transmitter. The second one is the receiver. The receiver is the toy car. This one here. This is the receiver. Because it needs a signal for it to operate remotely. Okay? And the transmitter is actually this one here. This is a transmitter. Because this is where we operate the toy car, okay, by operating this one or by depressing some buttons in here. If we would like that toy car to move forward, backward, turn left, then turn right. Okay, this is how it operates. A transmitter and a receiver will try to communicate through each other through radio waves. So radio waves meaning it got a frequency, and for this toy car here, the frequency is 2.4 gigahertz. I think that's the same as the frequency for what they call this microwave oven maybe, or cordless phone 2.4 gigahertz. Okay, so this one, if you try to operate this one, it might interfere with the operation of some of the things inside your house. Okay, so this is the transmitter, this is the receiver, and this transmitter and receiver communicates by using a radio waves, and the frequency is 2.4 megahertz. Oh, let's try to discuss. Let's try to discuss what is a transmitter. A transmitter is controlled by a microchip, or in some bigger things, it's a microprocessor. It's a computer thing, the one they are making at Silicon Valley. Okay? But for this one here, uh, the microprocessor or microchip inside is just very small. Okay? But it's a complicated thing. You could program that one to emit some signal for it to operate or to communicate with the receiver. Okay? So actually this transmitter here is this one here. It's microprocessor controlled, and this is where we trigger this toy car here. Trigger meaning if we try to trigger this one here, transmitter, for it to operate move forward, we can do this one by using this. This one here is the pulling inwards here is actually forward. Pulling this one forward is actually backward. And for it to operate, meaning to run going left or going right, is actually done by this one here. Okay? It seems it's got a, what you call this, it's just like the wheel of the hand wheel of the car. So if you want to go right, you turn like this. If you want to go left, you turn like this. While doing the forward, if it's forward and you want it to go to the right, you press this one here. Okay, then you turn it like that. So it will go forward, then it will turn right. Same true with the turn left. You push this one to go forward, and if you want it to move going to the left, just do it like this. Okay. And how could those what you call these manual buttons communicate with the receiver? As what I said a while ago, it's a radio waves. This one is emitting signal. The frequency is actually 2.4 gigahertz. So if this is transmitter, for this one to operate, it should have an antenna. But this one here, you got no, you cannot see any visible antenna here. According to the manual, the antenna is inside. So actually, if we try to, if this one here try to emit a signal, that antenna will try to intercept it. It's just like the cell phone, right? You cannot see any visible antenna, but there is an antenna inside. Okay? So if you try to trigger this one to move forward, this one will try to emit a signal. The radio waves is 2.4 gigahertz. This will be intercepted by the antenna. And inside this receiver, again, there's again a microchip. Because without the microchip, we could not process the signals that's coming in. So the microchip inside the receiver is also, will try to process what kind of signal is that one. Is that a signal for triggering the toy car to move forward? Is it a signal triggering the toy car to move backwards? Or is it a signal triggering the toy car to move to the right or to the left? So inside the receiver, there is the so-called decoder. This is too much electronics already for us to go to the inside thing of that one. I am just summarizing what a decoder could do inside the receiver. So a decoder, okay, converts that radio waves to motion. So if you trigger this one here for the toy car to move forward, this decoder will analyze. So upon analyzing, if it's going forward, then turn to the left, it will go to that direction. Okay, so that's the use of the so-called decoder. Okay, and there are some other things inside this receiver here. There is the so-called drivetrain, and there is the so-called servo motor. The one controlling the movement for forward or backward, that actually termed to a servo. Okay? The motor inside this one here is a servo motor. It's not a motor that continuously runs to rotate clockwise or counterclockwise. It's a motor, okay, in which if it receives a signal, it will just turn maybe 15 degrees to the left, 20 degrees to the right. Okay? So it's not a continuous rotation. So if you want to go to the left, it might tilt a little bit 15 degrees to the left. It's not totally one complete revolution. It's not. So for this one here, if you go to the left, it might just turn 15 degrees. And if you go to the right, it might just turn 20 degrees. And that is a servo motor. This servo motor is actually a very critical thing inside this toy car here. And actually that's the one, what you call this, controlling the operation of this one. If this moves forward and you want it to go to the left, so you rotate this one here to go to the left. So it will just turn 15 degrees to the left. Okay? Or it might go again forward. And if it recedes, so upon analysis that it should turn 20 degrees to the right, it will move forward, then it will turn 20 degrees to the right. So this motor here is very critical. And it's actually very, what you call this, it's accurate, you know. Whatever input you will give it to it, it will perform it, okay? Move forward, then move to the left, maybe move forward, going to the right. Or if you try to backwards it one, it might back up like that. So The one analyzing all these things inside is the microprocessor on the receiver. So there is also a computer here. It's still a small microchip, same as the first one. Because this one, it got a microprocessor to what you call this, activate the triggering and the steering if you want to try to operate this one here. And there's also a microprocessor for this one here. So the first computer and the second computer actually talk to each other through radio waves, and the frequency is 2.4 gigahertz. Okay. If you want to go further on how this decoder works, try to read something about decoder. Okay, decoder is actually, it receives a signal, okay, then it will try to convert that radio waves to motion. Is that signal going forward, or is that signal going backward, or is that signal going to the left, or is that signal going to the right? So that's the use of the so-called decoder. I want to discuss also one thing about this throttle commands. How fast will it move forward, and how fast will it move backwards? And that is actually what you call this, done by the so-called director. There is a director and the microprocessor which control the speed control. It acts like a speed controller. Speed controller meaning if you try to depress this one fully, according to the theory of this one here, if you try to push this one fully, it will go forward. But if it's fully, this director here or speed controller will try to give the maximum voltage on the battery of this one here. Okay, the full battery. So if you try to depress this one fully, it's very fast. But if you try to depress this one maybe 25%, okay, the battery that will be given to the motion will just be simply 25% of the battery voltage. So it depends on how you depress this one, okay, and that's the one how you could control the movement. Will it move forward not too fast or slow? So it depends on the depressing of the triggering button here. Okay. So if you try, I will try to repeat it. If this is fully depressed, that's very fast. But if it's only depressed 50%, of course the speed will be lesser, you know. And if you try to depress this one maybe 25%, it's going slower. So regarding the speed of this toy car here, it depends on how heavy our depressing may be. Did we depress this button here for going forward fully? If it's fully, that's very fast. If 50%, it's not so fast. If it's 25% depressed, okay, it's not so fast, it is slow. So the speed is actually controlled by this speed controller, and that is turned to as direct. Okay. Inside, there is also a drivetrain. Drivetrain is actually the one activating the, what you call this, it's just like in a car, you know, or normal car. For us to move to the right, there are some rods it will go, you try to depress this one and this one at the same time, so it will go to the left. Okay, and if you try to reverse it, okay, it will go to the right. And the thing that will control that one is actually turned to as the drivetrain. So the connecting rods, what you call this, controlling the wheels is actually controlled by this drivetrain here. This is a complicated thing. Okay, and this drivetrain here is controlled by the microprocessor inside the receiver. Okay, that's the summary of the operation of the remote controlled toy car. There should be a transmitter. This is the transmitter. There should be a receiver. The receiver is the toy car itself. This one got a microprocessor, and this one got also a microprocessor. So for this toy car here to operate, Uh, this transmitter and receiver will try to communicate through radio waves. Radio waves. We could not see this one. It's a wave, okay, flying through the air. It's a radio waves. And the frequency for this one here is 2.4 gigahertz. Okay, at least we now know how this toy car operates. There should be a transmitter and a receiver, and they try to communicate each other. So whatever command coming from the transmitter will be analyzed by the decoder inside this one. So if it analyzes that it should move forward, this should move forward. If it analyzes that the radio wave should be backward, it should be backward. If it analyzes that it should turn to the left, it should turn to the left. Okay, if it analyzes that it should turn to the right, it should turn to the right. Okay, and how fast is this one? It depends on the speed controller. Like what I said, if this is fully depressed, that's very fast. 50% it's slower, 25% it's slower. So how fast it is, it depends on how hard we depress the buttons. Okay, that's the operation of a remote controlled toy car. I will try to move this one here. Okay. I will just give some demonstration here. It will be something like this. Of course, if we try to operate our toy car, we should put this one to on. Okay, it's flashing red. And we try to switch on the transmitter. This like again here, pero we trigger the operation of this one. We put this to on. Free. Like what I said, if we push this trigger here towards us, it should move forward. That's forward. Okay, I push this one towards me. If I push this one backward, it should go backward. Okay, I could not do the turn left or turn right here. It might go down. This is forward. That's backward. Forward. Backward. If I will try to depress this one here fully, it's very fast. So the speed is actually controlled by how hard we depress the button. Okay. I depress fully. How far it is? Okay, it bumped the fence that I placed here. Okay, it's very fast. But if I will try to depress this one going forward, not so hard. Okay, not so hard. Not so hard. Backward, not so hard. Okay? Not so hard. Not so hard. Okay? So that's the explanation of what I said a while ago. How fast the toy car that will try to operate, it depends on how hard you depress the button or the triggering mechanism over here. For the left and right turns, it got a wheel over here. Right will you go like that, left will you do like that, while you're depressing the forward or backwards, okay? But I could not show you the left turn here. It might drop out from the table. Okay, good afternoon from Los Angeles. This is Professor J. De Los Reyes. If you want to comment on what gadget, again, the next time around that I will be discussing, try to place that on your comment. Good afternoon from Los Angeles. This is Professor David J. De Los Reyes. Okay, I will shut off this one. Okay, off. I will shut off the toy car. I place it off. I'll put it down so it will not be broken. Okay, I'll remove this one. That's a fluorine for demo. And I am done. So, good afternoon from Los Angeles. This is Professor David J. De Los Reyes.